Do you think it is possible to move an object without touching it? Then let me show you a magic trick. For this we need a PVC pipe, some pieces of paper and a cloth. So here I have a PVC pipe, I have a piece of cloth as you can see. Now I will rub this PVC pipe with the cloth, and there are some pieces of paper lying over here as you can see. And when I move this PVC pipe close to the paper, you can see they are getting pulled to that pipe. Isn't this amazing? Now you must be thinking, how does this magic work? But let me tell you something, this is not magic. This is science. To understand the science behind this, let me take you inside a PVC pipe. All the matter is made up of atoms. And if we look inside an atom, we will find three types of particles. One, negatively charged electrons. Second is positively charged protons, and neutral neutrons. In an atom, there will be equal number of electrons and protons present. Thus, they balance out each other's charge and makes the object neutral. Let's understand few facts about charges. Like charges repel each other, whereas unlike charges attract each other. Now let's see what happens when we rub two neutral objects. Let's say material 1 has loosely bonded electrons than material 2. So by taking energy from rubbing action, some of the electrons from material 1 will come out of the surface and move into material 2. So now material 1 has more number of protons than number of electrons, making it positively charged, whereas material 2 has more number of electrons than protons, making it negatively charged. Now the question is, what will happen when we bring a charged object close to a neutral object? Suppose I bring a negatively charged object near to a neutral object. The electrons on the near side of the neutral object gets repelled by the negatively charged object. Thus a small fraction of electrons get displaced towards the far side. So making the far side slightly more negative and the near side slightly more positively charged. So this process of charge separation in a neutral object is called charge polarization or charge induction. Now the negatively charged object will repel the negative charges on the far side and will attract the positive charges on the near side. But as the distance to the near side is less, the force of attraction is more than the force of repulsion. So if the neutral object is light enough, it will move towards the negatively charged object. So in our experiment, when we rubbed the PVC pipe with the cloth, the PVC pipe got negatively charged and the cloth got positively charged. And when we brought the negatively charged PVC pipe towards the pieces of paper, there must be charge polarization took place in the pieces of paper, and as the paper are very light, so it got attracted towards the PVC pipe. Let's see some more experiments based on the same principle. For this we need PVC pipe, one cloth and a cold drink can. So again we will rub the PVC pipe with the cloth, and when we bring it towards the Coca-Cola can, you will see what will happen. With the same principle, it is getting attracted towards it. Now let's see another experiment. So there is a stream of water coming out of the bottle, and as you show the charged PVC pipe, the stream of water gets deflected. And this is based on the same principle. Now observe the next experiment carefully, and you have to think what's happening now. So we take two balloons, they are touching each other, they are hanging from one common rod. So now we will rub each balloon with a piece of cloth. And we will leave them. So you can see they are running away from each other. Now we will try to push them together, but still you can see they are repelling each other. So can you guess why they are repelling each other? I think most of you guessed it right. So when we rubbed both the balloons with the same cloth, they must have developed similar charges. And as we know that similar charges repel each other, that's why the balloons were repelling. Now we know that an object can be either charged or can be neutral. So the question is there any way of detecting the object is either charged or neutral? Let's build an apparatus to do so. For this, we need a glass, one rubber sheet, a paper clip which we have unfolded as shown in the image, and two small aluminum foils. On one side of the paper clip, hang the two aluminum foils as shown, and the other side is pierced through a rubber sheet and it is placed on the glass as shown in the figure. In order to check whether an object is charged or not, we have to bring that object and touch it on the top end of the paper clip. For example, let's bring the charged PVC pipe we have and touch it there, and let's see what happens. As the PVC pipe is touched, we can see the foils are getting deflected. Let's understand what happened. As the negatively charged PVC pipe touches the top end of the paper clip, all the excess negative charges will flow to the aluminum foil through it. Thus, both the aluminum foil will acquire similar charges. And as we know, similar charges repel, that's why they were deflecting away from each other. Now we can say that if the foils deflect away from each other, that means the object is charged, or else it is neutral. Such an apparatus is called electroscope. This static electricity can lead to some large-scale natural phenomena like lightning. During thunderstorms, in clouds, there will be vigorous movements between the water droplets and air molecules. And this vigorous movements can lead to charge separation. And by some process which is not yet completely understood, the positive charges collect near the upper edge of the cloud and the negative charges accumulate near the lower edges. And there will be some accumulation of positive charges near the ground also. When the magnitude of accumulated charges becomes very large, the air, which is normally a poor conductor of electricity, is no longer able to resist the flow. Hence, the negative and positive charges meet, producing streaks of bright light and sound. We see the streaks as lightning, and this whole process is called electric discharge. In 1752, an American scientist named Benjamin Franklin is the first person who identified that the cause behind lightning is related to static electricity. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. No open place is safe during lightning. So stay inside your home with windows and doors shut. If you are outside, then stay away from all types of trees, poles, or any other metal objects. Squat low on the ground as shown in the image. This position will make you the smallest target to be struck.